Good morning, everyone. This is Jennifer, the presenter of Group 3. I am here to show you our colonization plan. As you all know, the Earth is dying because of hotter temperatures and soon will not be able to support life. With that in mind, humans must revert to the past and a more nomadic lifestyle. We must leave. Our plan is to colonize the icy moon, Europa. Yes, there are some troubles with that moon, but then again, nobody's perfect. Let's go over Europa. This moon is completely covered in saltwater oceans with a crust of ice and many underwater vents that produce thermal energy. The moon, however, can go down to a temperature of negative 260 degrees Fahrenheit, and its gravity is only 1.315 meters per second, a small amount compared to the Earth. It has a weak oxygen atmosphere. With that information, let's proceed with our plan. At first, a small shuttle would be sent to the moon to, for a lack of a better phrase, set up shop. The shuttle would contain robots and cryobots and the materials needed to make the colony. By the time the shuttle arrives in Europa, a second shuttle transporting the colonizers will launch into the atmosphere. It will contain about 1,000 humans. The robots and cryobots would drill a hole into Europa's ice crust and either find or even build an ice pocket that is also near one of the underwater vents. Within this ice pocket, a small colony could exist. If there is not enough room for our expected 1,000, more ice pockets could be found or built.
Giving Jennifer a break, here's Sebastian from Group 3. Let's continue on our colonization plan. The ice pocket would not only shield us from Jupiter's deadly radiation, but also decrease the temperature. We would be located near an underwater vent spewing thermal energy, so we would be relatively warm. We would, of course, place a covering on the walls against the ice. But it's not that easy. There are still some challenges, such as the constant need for food and water, energy, and oxygen. The food problem could be solved using hydroponics, growing plants without soil, although some fertilizer will have to be brought in order to create the solution for the plants to grow. There are also multiple types of free-flowing aquatic vegetables, such as the seaweed species Gracilaria, which in multiple countries is used to make types of gelatin. It is edible. For water, well, we would be surrounded by it. Although a viable solution has yet to be found to purify salt water, a large-scale reverse osmosis membrane could be used. This is a process that takes out various particles in water, leaving only pure water and healthy bacteria. We could also use urine purifiers, but only, hopefully, in desperate cases. A special shout out to Carlos for that idea. Oxygen is already present in the atmosphere of Europa. We only need to strengthen it. We can do this by electrolysis and artificial photosynthesis. In electrolysis, water is decomposed into oxygen and hydrogen. An electrical source is connected to two pieces of inert metal placed in water. When powering it, hydrogen is produced at the negatively charged piece and oxygen is produced in the positively charged piece. Artificial photosynthesis is simply recreating the process of photosynthesis, but without plants. And of course, we would have some plants for food. But we need energy to power all this. For energy, we envision the use of a muon-catalyzed fusion reactor, such as the ones used in 2001: A Space Odyssey. And if we are talking about A Space Odyssey, Europa is actually colonized by aliens in the third book. Muon-catalyzed fusion is a much safer type of nuclear fusion, at room temperature. Muon's subatomic particles are placed into an atom, causing its particles to smash into each other. Now, let's go back to Jennifer.
Here is a picture of our space colony courtesy of our engineer. As you can see, there is an inflatable dome which would be on the surface of the ice. This dome would have a hatch that the space shuttle would land on. In that dome would be the muon-catalyzed fusion reactor away from where the humans would live. Below that would perhaps be a level for storage, technology, electrolysis, artificial photosynthesis, and etc. Below that would be the living quarters with bunks, a common room, kitchen and/or kitchens, and of course entertainment. A third level would be for the production of food with hydroponics and storage. and the lowest level would be for waste, the growing aquatic plants, and reverse osmosis membranes. For our space shuttle, here is another picture. This shuttle will be able to hold 1,000 people, and a much smaller one will be made for the robots in the first mission. As you can see, it has 3 thrusters that would propel the spaceship and solar panels on its arms, and at the end of each arm would be a smaller thruster on the side. This will turn the shuttle gradually, so the process of 1G would be recreated. We would need more technologies for this mission too. Neon catalyzed fusion is not a practical energy source as of now. With time and resources, however, it could progress into something viable. A reactor must also be minimized in size to fit into the colony. Gravity is a problem in Europa too. Its force is incredibly small. And since the colony cannot spin to create artificial gravity, the use of exoskeletons or some type gravity-resistant boots must be used to fight against bone weakening. These technologies are in development, already coming along, especially the exoskeletons. Cryobots will also be needed to penetrate Europa's ice. These are probes with ends that heat up, letting them cut through ice and can travel through seas. Prototypes of these machines have already been made, such as the ice mole, which is already planned to be sent to Europa for research. All in all, Europa seems to be near perfect for colonization. There are some problems, of course, but then again, they could be solved. Perhaps the impossible will soon be possible thanks to the fighting spirit of the human race. Thank you all.